All right, so I'm going to just very briefly go through some of the highlights from the Penny lab. And in this lab, you were able to see both synthesis and single replacement, and also double replacement, actually. I didn't ask you to address double replacement in the lab because we hadn't gone through double replacement, but I'm going to explain what's happening in just 1 second. The pennies that you saw, normally pennies look very dirty, and that's actually a misconception. Obviously, they have bacteria on them, but they're not actually as dirty as we think. Pennies have copper on their outside coating, and what happens over time is pennies are able to react with oxygen, and those pennies which have copper, the copper reacts with oxygen and it forms copper 2 oxide. The copper has a 2+ charge, so this is copper oxide here. So if I balance this copper oxide, this is why pennies look dirty. They're not actually dirty, it's actually copper oxide that's on the outside of the penny. So if I then take that dirty penny, and I put dirty in quotes, and I add it to vinegar. Vinegar is acetic acid. So I'm going to add my dirty penny in quotes, and I'm going to react that with acetic acid. Okay? And so if I react that with acetic acid, what you should notice, and this is why I eliminated one of the questions, you weren't expected to know this, but now you can do double replacement reactions. This is going to be a double replacement reaction. The copper is going to form a compound with acetate, and the hydrogen is going to form a product with oxygen. And so what your products are going to be, copper has 2+ charge, acetate has a 1- charge. You're going to end up with copper acetate. Okay, and your other product is going to be water. So the important thing for you to know is that in solution, and this gets into figuring out solubility rules. Sorry, your other products can be water, because hydrogen combining with oxygen would be just water. All right, so I'm going to really quickly balance this for you guys. All right, so the important thing for you guys to know is this copper ion is going to be in solution. All right, and because in addition to vinegar, we put salt in there, there's also going to be chlorine in there. So I'm simplifying this because there's some concepts that we haven't covered, but we're going to assume that the copper is going to form a compound with the chlorine. All right, so what we're assuming is that the copper is going to form a compound with a chlorine, and when it also reacts with oxygen, that's how we get this blue substance, and that is called malachite. Okay, so these are the pennies that you did not rinse, that you allowed to stay out, allowed to react with oxygen. So you had the copper ions, you had the chloride ions, and now you had the oxygen, and it forms this compound called malachite. All right, let's talk about the very last thing that you did. You had your solution, which had copper ions and chloride ions in them because you added salt, and then you added a nail. All right, so that was the last part. We started with copper oxide, right? We allowed it to react with our vinegar to form copper acetate and water. Okay, that copper acetate is mostly just copper ions that we'll see. Okay, and the copper ions reacted with oxygen and chlorine to form that malachite, but then also the copper is going to be left in solution with the chloride as well, because we kept that solution. We didn't take that, we didn't dispose of that solution. So when we added an iron to that copper chloride solution, this now is going to be another type of reaction, not synthesis, not double replacement, but this is a single replacement reaction. So we allow the iron to react with copper. It's going to kick the copper out because iron is higher on the activity series than copper is. And so what is actually formed, since the iron has a 2+ charge, is FeCl2 and then copper. All right, so why does this matter? Well, when I originally put the nail in, it kind of has this silvery looking color to it. Okay, and then when we allow it to react with the solution, the copper chloride solution, what happens is the iron is going to be kicking out the copper, right? So the iron is going to form a solution with the chlorine, and what's going to be left as a solid on your nail is that dark color copper. So that's why your nails turned a darker color, because it was copper being deposited on the nail itself. As iron was kicking the copper out of solution, the copper was able to form a solid on the nail. All right, so that's what happened in this lab. The reason why it's so cool is you see not only a synthesis reaction, a double replacement reaction to form those copper ions there, but then you also see a single replacement reaction.